Arrhenius, an acid that dissociates into hydronium or hydroxide ion aqueous solutions.
So acids will form hydronium ions when they're in an aqueous solution.
And bases will form hydroxide ions when they're in an aqueous solution.
So for Bronsted-Lowry, the definition of acids, they're the things that they're the things that donate the hydrogen proton.
And then for the bases, they're the acceptors of the protons.
And then you're going to have your conjugate acid, which is going to go with your base, and it's going to end up with the hydrogen ions.
And the conjugate base, it's the same thing, but it's going to go with the acid, and that loses the hydrogen ion. So naming acids and bases. So if it ends in the suffix -ate, it'll be ic and then the acid name. An example of this is sulfuric acid, and if it ends in -ite, it'll be ic, that would be O-U-S, then acid, and there will be a few R's, like chlorous acid, and then I will be hydro, then the element, and then acid. And I like this marker. Okay, that's it. And then the exception is ammonium, which is NH3.
Okay, we're continuing the types of acids and bases. And if you don't have anything, I will show this at the end of the video, so that way you can fill in any blanks you missed. Okay, back to naming your acids and bases. So, if you have sulfuric acid and the IC ending means that you would originally had an ATE ending, that's going to be sulfate. Chlorous is going to be chlorite, because that ITE ending turns into that OUS. And then this one is going to be chloride, because if you have that IDE ending, then it'll have that hydroic acid. And remember your exception, all bases will end in hydroxide except for ammonia, which is NH with a subscript of 3, and that should be a subscript. Now for your strong acids. You're going to have hydrochloric acid, okay? You're also going to have nitric acid. And you can put the nitrate in parentheses if you want, but I'm not going to. Then you have sulfuric acid, which is H2SO4. Actually, I think I will put these in parentheses. This is going to be hydrobromic acid. The next one's going to be your iodic acid. Okay, and this next one is going to be chloric acid. Okay? For your strong bases, you're going to have sodium hydroxide. So you're just going to put NaOH, and that OH stands for hydroxide. Then you're going to have potassium hydroxide, which is KOH. And then you're going to have calcium hydroxide as your next one. And after that comes barium hydroxide. Next we have our practice problems. Okay, so we're going to start with naming first. This is one of our strong bases, NaOH. That's going to be sodium hydroxide. H2SO3. That is going to be sulfuric acid, I think. And after that is calcium hydroxide. Next, we're going to practice the formulas. For hydrofluoric acid, it's just going to be HF, because it's just fluoride and hydrogen. Next, you have your carbonic acid, so it's going to be carbonate and hydrogen. So I think that'll be H with a subscript of 2, and then CO3. And then you're going to have cobalt hydroxide, which is going to be that.